Ever wondered what causes the ground to shake beneath your feet? The sudden, powerful tremors that make buildings sway and roads crack are phenomena that have intrigued and terrified humans for centuries. Let's uncover the secrets behind these natural occurrences. Let's dive into the fascinating world of earthquakes. These natural events are more than just ground-shaking episodes. They offer a glimpse into the dynamic processes happening deep within our planet. Understanding them can help us better prepare for their inevitable impact. An earthquake is the shaking of the Earth's surface caused by a sudden release of energy. This energy release occurs when stress, accumulated over time in the Earth's crust, is abruptly freed, resulting in seismic waves that travel through the ground. Earthquakes primarily occur due to tectonic plate movements. These plates, which make up the Earth's outer shell, are constantly in motion. The interactions between them, whether colliding, pulling apart, or sliding past one another, are the primary drivers of seismic activity. The Earth's crust consists of large slabs called tectonic plates. These plates float on the semi-fluid layer beneath them, known as the mantle. Their movements are slow but relentless, shaping the Earth's surface and causing occasional, yet often catastrophic, earthquakes. Earthquakes predominantly occur along the boundaries of tectonic plates. These boundaries are areas where plates interact, making them hotspots for seismic activity. The immense pressure and stress from these interactions eventually cause the ground to shake, resulting in an earthquake. There are three main types of plate boundaries, each with distinct characteristics. Convergent boundaries are where plates collide, leading to intense seismic activity. Divergent boundaries, on the other hand, involve plates moving apart, creating rifts and new crust. At convergent boundaries, the collision of tectonic plates generates immense pressure. This pressure builds up until it's released in the form of powerful earthquakes. These types of boundaries are often associated with some of the most destructive quakes. Divergent boundaries occur where tectonic plates gradually move apart from one another. This movement creates space for magma to rise, forming new crust. Though generally less violent than convergent boundaries, these rifts can still generate significant seismic activity. Transform boundaries are unique because they involve plates sliding past each other horizontally. The friction between the sliding plates causes stress to accumulate. When this stress is released, it triggers earthquakes, which can be particularly destructive due to their shallow depths. Earthquakes often strike along fault lines, which are fractures in the Earth's crust where two blocks of land have moved past each other. These fault lines can be horizontal or vertical and are critical zones for seismic activity. A well-known fault line is the San Andreas Fault in California, which stretches roughly 800 miles. It marks the boundary between the Pacific and North American plates and is notorious for its frequent and powerful earthquakes. When an earthquake occurs, it generates seismic waves that radiate outward in all directions from the epicenter. These waves travel through the Earth and can cause significant shaking and damage as they move. There are several types of seismic waves, including primary waves, secondary waves, and surface waves. Each type of wave moves differently and affects the Earth's surface in various ways, contributing to the complexity of an earthquake's impact. Primary waves are the fastest seismic waves and can travel through both solid and liquid materials. They compress and expand the ground as they move, making them the first waves to be detected by seismographs during an earthquake. S waves travel more slowly than P waves but are crucial in understanding earthquakes. Unlike P waves, S waves can only move through solid materials. Their motion causes the ground to shake perpendicular to the wave's direction, contributing significantly to the quake's impact. Surface waves are the slowest but most destructive seismic waves. They travel along the Earth's surface and cause severe ground shaking and displacement. Their ability to move in complex patterns results in extensive damage to structures and landscapes during an earthquake. Seismographs are essential tools for measuring and recording earthquake activity. They detect seismic waves, allowing scientists to analyze their speed, direction, and intensity. This data helps in understanding the earthquake's origin and predicting potential aftershocks and future seismic events. The Richter scale is used to quantify the magnitude of an earthquake. By measuring the amplitude of seismic waves, it provides a numerical value that represents the energy released. This scale is crucial for comparing the strength of different earthquakes and assessing their potential impact. Magnitude and intensity are two important aspects of understanding earthquakes. Magnitude refers to the total energy released during an earthquake, while intensity measures the effects and damage experienced at specific locations. Both metrics are vital for comprehensive earthquake analysis and response planning. The 2004 Indian Ocean earthquake, one of the most devastating in history, triggered a massive tsunami, affecting 14 countries and causing immense loss of life and property. Measuring a magnitude of 9.1, it underscored the catastrophic potential of powerful seismic events. Predicting earthquakes remains a significant challenge for scientists. Despite advancements in technology and understanding of tectonic activity, accurately forecasting the time, location, and magnitude of earthquakes is still beyond current scientific capabilities. Research continues to improve predictive models and early warning systems. Being prepared for an earthquake can significantly enhance your safety. Assemble an emergency kit with essentials such as water, food, and first aid supplies. Securing heavy furniture and ensuring structural integrity can mitigate potential hazards within your home during a quake. During an earthquake, immediate actions can save lives. Drop to your hands and knees to prevent being knocked over. Take cover under sturdy furniture to protect yourself from falling debris. Hold on until the shaking stops to ensure your safety from sudden movements. After an earthquake, quickly assess your environment for injuries and structural damages. Be cautious of aftershocks, which can follow the main tremor. Check for hazards like gas leaks and damaged electrical wiring to prevent further accidents and ensure a safe environment. After an earthquake, it's crucial to check for injuries and damages. Ensure everyone's safety first and administer first aid if needed. Be aware of potential hazards like gas leaks or structural damage. Always be prepared for aftershocks, which can follow the main quake. Earthquake engineering plays a vital role in minimizing damage. Buildings designed to withstand quakes incorporate flexible materials and shock absorbers. These innovations reduce the risk of collapse, saving lives and reducing economic impact. Investing in earthquake-resistant infrastructure is essential for vulnerable regions. The Pacific Ring of Fire is notorious for frequent seismic activity. This area, encircling the Pacific Ocean, is home to numerous active volcanoes and fault lines. Countries within this zone must remain vigilant and adopt robust earthquake preparedness measures to protect their populations. Climate change doesn't directly cause earthquakes, but it can influence them. Melting glaciers and shifting water masses can alter the stress on tectonic plates. While the connection is complex, understanding these interactions is crucial for comprehensive earthquake risk assessment and mitigation strategies. Stay informed and prepared to enhance your safety during earthquakes. Familiarize yourself with local emergency plans and participate in community drills. Knowledge and readiness are your best defenses. Subscribe to our updates for more insights and tips on staying safe during seismic events.